Hi. The moment we think of linear algebra, it sounds to us that it's having a lot of stuff on vectors, matrices, vector spaces, indices, tensors, subspaces, transpose, so on and so forth. But to me it sounds like it's vectors with operations. Only two basic operations, that is multiplication with a scalar and addition of vector. So before that, let me begin with what is a vector. A vector has many definitions. Physics book describes vector as a property, something which is having a magnitude and direction. And if you take mathematics, a vector is, having a particular components and is abided by certain operations. And for a computer scientist, for example, a vector is nothing but a list of numbers, ordered numbers rather, or a spreadsheet. Matrix is a spreadsheet with a lot of interlinked data. All this. But if you have decided to study linear algebra, you have to start with something very fundamental, that vector having a direction. A vector is an arrow, and the arrow is always at the origin of a coordinate system. That is the fundamental that you should begin with to understand linear algebra. So, if you think that this is a vector, and for a physicist point of view, it can be moving freely. It is having a certain magnitude and direction. But for linear algebra, no, it can't move, but it gets fixed to a coordinate system. If I take the coordinate system like that, this vector is fixed at origin. So, in all the cases of linear algebra, vector is something gets fixed to the origin, and this can be given by a notation something like this. I think, this is 3 and 2, so I can denote it like 3, 2. I can represent like that. This is a vector. A computer scientist will write like that. 3, 2, a column vector. This is, you want to put it as an x and y coordinate system. And no matter what you do, this vector is fixed to the origin. So when you have this concept, like in linear algebra, vector is getting fixed to the origin, and it will have certain, measure, pointed to certain point, space point there. But it should not be denoted as 3, 2 as in a geometry. It's a vector. It is not a space point. It is a point getting connected to the origin. So it's a vector. So when this is a vector, it should be denoted something like this. What we do in computer science or mathematics. This is a vector, rather we write something like that. Vector V is this, something like that. So when we have this kind of a vector represented on a coordinate system, we can perform certain operations on this. In linear algebra, we have 2 such operations. There you can see in the figure that I have shown how a vector gets joined to the origin, and you can have modifications of that based on the operations of linear algebra. So I have 2 operations. First one is adding vectors. Adding 2 or more, vectors. It should have certain rule. You can't add as you wish. The second point is multiplying with a scalar. That's it. So, if you have two vectors, how do you add? I will show you there in the picture as a demonstration. But here on the board, you can see that. I have taken certain, vector. I would like to represent there. Another vector, let's say, in this direction. Now this is my vector, another vector. Maybe I represent with W. This is, let's say I say 1, 1. Minus 1, 1. Okay. Because positive x is, 3 parts there, 3 units. So 3, and I say 1, 2. So this is 3, 2, and this is minus 1. Let's say I put it as minus 1 there, and 1 along y-axis. So I have two vectors. Now what do I do to add these two? The basic rule is, when you start from the origin, you have two vectors. Take any one vector. I take v, let's say. I move along that, and I reach to the head of the arrow. Then you have to move in the direction of the second vector. That's it. That means you have to translate this vector w there, and it becomes another vector on that. Now there is no vector here. Then join these two. This is how we get u plus v and w, v plus w. This is how the general operation, addition. Then you may have a question, why not we add something like this? Now I can join like this, right? I can join like this. This is also an option. Why I should not do it? No, you should not do it because of the vector rules. When you start, I said in the beginning that when you start at the origin, you move along with, along the direction of one vector. You don't have a chance to, come back and move in the other direction. That is how you have to complete both vectors. Or else you can choose this vector, go there and move in the direction of the vector, another vector, and there you end up. But if you join like this, you are not having an option, to move, to cover both the vectors. So it's not the rule of the vector addition. You have to join the tail of the second vector to the head of the first vector. No matter how many vectors comes, it should be joined in this way. That is how we need to add vectors. The same, if you translate this v there, you will end up with the same vector there. This is a fundamental rule. You can't add as you wish. The second rule is multiplying with a scalar. How do we multiply vector with a scalar? See, now I'll take the vector v. I have vector v there. Vector v is 3, 2. Now I want 2v. I want to multiply 2 with v. And simply, you know it, what it is. It is 6, 2, 4. 2 times 3, 6, 2 times 2, 4. What happened to the vector, if you see there, if you see there, what happened to the vector? It is scaled, you see that, 6, 4. You know, it is going to that point, 6, 4 point. It is moving to somewhere that point, covering, I mean, I can show you with a different color there. It is scaled to that point. Now this is a vector where I can write 6, 4. What has happened to the vector there? You can see that when I multiply with a scalar, it is scaling the vector. The same thing, you check if you take another example. I want half to be multiplied with v. Then what do I have? 3 by 2 and 1. Means what? I have to move 3 and a half. I take this, this is my original problem, right? 3 by 2. Yeah, correct. So 3 by 2 is half, right? There, I end up there. And it is 1. Y-axis is 1. So this is my vector. This is my modified vector. You can see there. Either it is scaling or doubling the vector or making half of it, or you can also do the inverse of it. If I multiply with minus 1.5 times v, what it should be? 3 times 1.5 comes 4.5, and 2 times 1.5 is 3, right? Yeah, I'm sorry, minus 3. Now, when you have this, you can see that, both are minus. That means your vector is having negative x, negative y. It should be coming like this. So it is scaled to maybe minus 4.5 there and minus 3 along y-axis. You can see that. That is the beauty. If you understand the very fundamental aspect, when you multiply a vector, you are scaling the vector. You can even flip the vector to the other side. When you add vectors, you have to stick to a rule that I have explained. And when you multiply with a scalar, you have to do simple multiplication like this and see how this is going to give you a new version of the vector. Thank you.